So before, what we did was we just took the numbers from the equation. We even bypassed the ice chart, and we just said that the pH, well, in this case, this is a base. So I guess what we said was that the pOH was equal to the negative log of the Kb plus the log of the salt over the base. And we just plugged those numbers in. We looked up the Kb. We found that it was the 1.8 times 10 to the minus fifth. When you look it up, that's what you'll find for the NH3Kb. And then the log of the, and this is the salt, so 0.4 over 0.8, and that's how you get your pOH. So that's what we were able to do before. Now, we don't always have this lying around, and there can be some really useful reasons for making a buffer. We call it in situ. And what that just means is it just means we're making it all at once from a reaction. So we're just kind of making it, and then we can do something with it once we've made it. Kind of like you don't have to like clean it all up and do all this extra stuff with it sometimes. So what we're going to do is I'm going to actually make that buffer from this reaction. So to do the reaction, you either need a weak base and a strong acid, this is not a strong base, but you either need a strong base and a weak acid. Those combinations reacting together will make a buffer. And I'm going to do this kind of a long way, but when you get really comfortable with ice charts, when you get comfortable with ICF charts, then that's where you it really makes it easier. So for this ICF chart versus the other kind, I'm going to first write out the reaction. So NH3 plus HCl that's a base. It's going to grab the H. So that gives me NH4. That's a positive ion combining with, and it'll just grab that negative Cl. But you can also write them separately if you prefer to write them separately. The Cl won't affect any pH in the solution because it would make a strong acid if it wanted to with water in it. It doesn't want to make a strong acid. So then what we have is we have a reaction, and to get those numbers, because that's all I need. I already have this part of it, right? So to get those numbers, to get that same pOH, then I just have to know what is this one after reaction and what is this one after reaction. So the way that goes down is I'm going to write this as a liter. So I have 0.300 liters of NH3, and I'm going to go from liters to moles. This is all of the NH3. And then from moles of NH3 to moles of NH4Cl. Notice that those are all 1-to-1, so that's going to be a really easy one. I'm going to go ahead and set up the other one after I fill this in. So that is 2 in 1. That comes from this molarity here. Don't forget that that unit is the same thing as saying a mole in a liter. Then I'm going to take the other number, 0.200 liters of HCl. And that's in 1 liter of HCl. And it says that I have 1 mole of HCl in this. And then I'm going to go from moles of HCl to moles of NH4Cl. So that's 1-to-1. So when I do that math, I can actually kind of do that in my head. That the 0.3 times the 2 is going to be the 0.6 moles of NH4Cl. And then the 0.2 times 1 is going to be 0.2 moles of NH4Cl. So between the two of them, the one that is giving me the excess is this one. This is my limiting. So that number right there is going to be not the number that I use. So that gives me my salt amount. And you might be saying, but wait a second, how come over here, if you're trying to do the same one? Well, remember, when we put these in, you're going to see what happens. I can put those in as a mole, and it's okay. So I'm going to show you what happens and how you end up with that same situation. And then if we have excess, remember I got to take my limiting, the 0.200 liters of HCl. And in 1 liter of HCl, I have 1 mole of HCl. And then in 1 mole of HCl, I've got 1 mole, and I'm turning into the excess, so of the NH3. So that means that I have 0.2 moles of NH3 that are used. How much did I have to begin with? Well, right here, I had 0.6 to begin with. Do you see the 2 times the 300? So I had 0.6 moles of NH3. So that tells me that my difference is 0.4 moles of NH3. So if we go back to this Henderson-Hasselbalch, I can say that the pOH is equal to the negative log of the 1.8, because that's the number from the chart for NH3, plus the log of, and then the salt goes on top. Here's how much salt I made, 0.2 moles over 0.4 moles. And you can kind of see that ends up being a half, and that's a half. So those are actually the same buffer pH. So you can see that I've made a buffer when I do a reaction like this. There's one more thing for me to add, though, on what you have to have. You always have to have more of the weak thing for you to make a buffer. It always has to be more, and there has to be less of the strong thing. So that's how you make something in situ using the old method of using limiting reactant math to solve this. I'll be showing you how to solve it with an ICF chart, which makes it so much easier to see, and it's a lot less work, in a minute.